In this video, we're going to talk about velocity versus time graphs. Right? So we've done motion graphs before. We've had position versus time, which tells you where something is located over time. Well, here we have an object that has a changing velocity over time. And we know that is called an acceleration. Right? And we can plot what that velocity is over time on a velocity versus time graph. Right? So we're measuring the velocity and we're plotting points as time passes. So really, when I look at this graph, each of these data points is an ordered pair of time. This data point is at 3 seconds. And when the object is 3 seconds into the motion, it has a corresponding velocity of 3 meters per second, right? And if you were to plot these points, you could tell how fast and what direction, right? We're dealing with velocity. This object is at any point in time. Remember in math class, we deal with an X and a Y axis, but now we have a T axis and our vertical is V or velocity. The important thing to look at in these graphs that tells you the most information is what is the slope of the line. And if we were going to calculate slope, we would do the rise over the run. We would be going up some number of meters per second of velocity and going right time. So our slope would be calculated by finding the change in velocity over time, which again, that is the definition of acceleration. So just as position time graphs told you the velocity by finding the slope, well, now on a velocity time graph, the slope is going to tell you the acceleration, how the velocity is changing for that object. So let's look at some different types of slopes you might see. If there is no slope, then there is zero acceleration. And therefore, there is zero change in velocity, and we would say that that object is moving at constant velocity. Our toy cars in our lab all moved at constant velocity, and you would see a horizontal line on the velocity time graph for each of those cars. Now, when you get a positive slope, you have a positive acceleration. You're adding velocity. If you have a negative slope, you have a negative acceleration. You're subtracting velocity. Now, it's important to understand that just because you're adding velocity does not necessarily mean you're moving right. So let's look at a couple different situations here. All right, and I've got them kind of marked. We're going to walk through a couple different situations here. So depending on the direction that you are accelerating, and again, it's helpful to think of acceleration like a push or a pull, right? Well, in this case, this velocity time graph has a line on it that has a negative slope. So this would be an object that is being pushed to the left, right? Its velocity is going to change. Well, what is its velocity at the start? At time of 0, right here, we have a data point up here. We have a positive velocity value that is high up on the graph. So this car starts fast and it starts moving to the right. Let's call the positive direction to the right. However, if you're moving to the right, but you're getting pushed to the left, you're going to slow down. And sure enough, the velocity goes down, down, down. And at about this point, after some period of time, the car now has no velocity. So it went from having fast velocity to the right to having none. And then it continues to lose velocity, which is actually gaining velocity in the negative direction, which is now a car that is moving to the left, right? And speeding up. So you can imagine an object moving to the right, slowing down, coming to a rest, and then rebounding the other way. When I rolled the cart up the ramp, and gravity stopped it and then sped it back down. This is what our graph looked like for rolling a cart up a ramp and letting it come right back down. Now let's look at this other situation. All right. What if this car is moving to the left up the ramp? Right. Well, it'd be fast, moving left, so we have a negative velocity. Gravity, in this case, would be moving in the positive direction. It would be getting a push in the positive direction, and it's going to slow down, and it's going to reach zero velocity. Anytime you see it crossing this axis, it's going from a left velocity to a right or a right to a left. It's changing direction. Right? And in this case, it changes direction here and then starts moving in the positive direction with a continued positive slope, right? And we talked about the direction of velocity and direction of slope, right? Here we see that. If I have negative velocity values, but a positive slope, right? If we have different signs, then we are have an object that is slowing down. But once it changes direction, we still have a positive acceleration, and our velocity values are now positive, and so we see an object that is speeding up, right? And again, anything above the axis, it's moving to the right. Anything down below the axis, moving to the left, right? So hopefully These two graphs give you a sense of velocity time graphs. I know it is a little tricky when we've been learning about position of a car over time and now seeing similar looking lines, but they now represent changing velocity. But if you can wrap your head around what is really measured on this axis and continue to remind yourself that the slope of this line represents how the velocity is changing, its acceleration. And then just continue to look in the motion at what key points do you know? Do you know what the car or the object is doing when time starts? Is it moving right or is it moving left? Is it fast or is it slow? And then what is it doing later? Is it still moving right? Or is it now moving in another direction when we would have changed direction? Is it moving fast or slow? Right? And we can plot some values. And we'll typically also plot the position time graph above the velocity time. So you would see where it's located as well. And you would see the slopes on that position time graph that would correspond to these velocity values. So I hope this helps give a little bit of direction here on how we might analyze a velocity time graph. They certainly take some practice. But again, if we can figure out the slope and remind ourselves that velocity has direction and that is what we're measuring. This is what the speedometer is reading. And we have a compass telling us which way we're going as well, right? So good luck, and I'll hit you with the next video.